everyone. My name is Dr. M. Nagaraju, working as Assistant Professor in the Department of CSEA and ML in Institute of Aeronautical Engineering, Hyderabad. So today we will try to see the continuation topic of our previous session. That is, we are going to talk about the definitions and terminologies related to the module 2. So in this particular video, we are going to discuss about some of the definitions related to the procedural knowledge. We are going to talk about the declarative knowledge. We will try to understand what do you mean by logic programming, and we will try to understand what do you mean by this inference engine. And we also try to see the different types of expert systems that are available in the artificial intelligence. And in the meantime, we will try to observe what do you mean by this forward reasoning and backward reasoning more clearly. Even by taking some examples also, we will try to understand these concepts wherever necessary. Coming to the point. So if we talk more clearly, so what do you mean by this knowledge and intelligence that we have seen in the previous session? That is, in order to exhibit the intelligence, it definitely requires knowledge, even for the humans and even for the machines. But when it comes to the first point, that is about the procedural knowledge. If we talk about the procedural knowledge, let us try to take one example and we will try to understand. So if you want to interact with a person and you are unable to understand his language, so then definitely you will not be able to give a response or deliver any action. So this is a very common point. It is a very general point, we can say. Means until and unless you understand what the others are speaking, so you will not be in a stage to give responses to it. So here, having a good communication, that completely depends upon the way how you are understanding. In the similar way, how the AI machines are behaving, it completely depends upon the way how it is understanding the knowledge that is given by the person from the outside. Okay, so this is the same with the intelligent behavior of the agents also. So the AI agent works by discovering the environment and applying the knowledge. So first of all, he is going to learn from the knowledge whatever we are supplying from the outside world. So that based upon that knowledge, it is going to learn something, and from that it is going to do some kind of works, we can say. It is going to do some kind of works in the sense what activity we have given to that machine, it is going to exhibit that machine by applying the knowledge we have given. So without the knowledge, we can say that it is not going to exhibit any intelligent behavior. So the exhibiting of intelligent behavior by an AI machine completely depends upon the knowledge, we can say. So how many types of knowledge are there? So knowledge is not a simple point, or knowledge is not a single point, so that we can discuss it in a general way. Why? Because there are different types of knowledges that are available. So when we talk about artificial intelligence especially, these knowledges are of two different kinds. One we can say that the procedural knowledge, and another one is called as a declarative knowledge. So what do you mean by this procedural knowledge and declarative knowledge? We will try to understand here. A representation in which the control information which is necessary to use the knowledge is embedded in the knowledge itself. So what is the primary point here? Here we require knowledge. That is very, very important. So in order to make use of this knowledge, we need to have certain kind of representation. We need to have certain kind of representation which is going to talk about the control information. So what do you mean by this control information? I mean, this information is going to tell which knowledge to be used at what time. Why? Because all the knowledge you cannot apply at the same time. So based upon this problem statement, or based upon the state of your problem, here the knowledge applying of knowledge type is going to be different. So here the procedural knowledge is going to have such kind of information. What is that? About the control information, means which knowledge need to be applied at what time. So we can take these computer programs, directions and recipes are certain kind of procedural knowledge. Okay, so we can, in simple words, we can say procedural knowledge is going to talk or explain about the way how we are going to solve the problems. In simple words, we can say it is a step-by-step process. Procedural knowledge is going to show or give us a step-by-step process how we are going to solve the problems. So this step-by-step process even we follow when we are developing certain kind of computer programs. And even when we are making use of these directions also, we need to follow some step-by-step procedure. And at the same time, when you are preparing certain kind of recipes, you need to follow this kind of procedures. So we can say that the examples for this procedural knowledge means where this procedural knowledge we are making use means in computer programs, showing some kind of directions and preparing some kind of recipes. So along with this procedural knowledge, we are also having the declarative knowledge also. Okay, so the real difference between this declarative and procedural knowledge is completely depends upon the control information. It completely depends upon the control information. So in simple words, we can say that the procedural knowledge is going to have the control information, but whereas the declarative knowledge will not have this kind of information. Okay, we will try to see more clearly about the differences now. So if you talk about this procedural knowledge, we can say it is going to be described how the problem is solved. Means this is a particular word we need to concentrate. How? That's why we are saying that it is a step-by-step procedure. Means how we are developing the programs. Okay, how we are preparing certain kind of recipes. Okay, so such kind of explanations we are going to see in the procedural knowledge. And even this procedural knowledge we can call it as imperative knowledge also. And it is also going to provide the direction on how to do something. That's why we say that every time it is going to show us, it is going to give us a step-by-step representation of the problem, how it is going to convert into the solution. So this knowledge, so means we can say this procedural knowledge is a knowledge which we can directly apply to a particular problem statement. We can say that it is a ready-made knowledge, we can say. Means the procedural knowledge we can directly collect it from the expert systems and we can apply it to a particular AI problem to get solved. So what it includes of? The procedural knowledge is going to include some rules, some strategies, some procedures, as well as some kind of agendas. Okay, so we will try to learn about this procedural knowledge more clearly in the coming sessions. Coming to the declarative knowledge. So that is the other side of the declarative knowledge. So this is a one particular word where we need to concentrate. So as we have seen, the procedural knowledge is going to concentrate how. Here, the declarative knowledge is going to talk about what. Okay, so why? Because the declarative knowledge is going to have a lot of concepts, lot of facts, and lot of objects that are represented in the form of declarative sentences. So because of this statement, we can say that the Prolog is a declarative language. Okay, so this declarative knowledge is going to have these things, concepts, facts, objects. Okay, so this declarative knowledge is going to describe what are the concepts we are using, what are the facts and objects we are using, and how we are resolving the problem. Means what are the main things we have used in order to solve a particular problem. It is also going to tell what are the results it is going to come. But it will not be in a stage to express how the results has came. Only just it will talk about what are the concepts, facts, and objects you have used in preparing a program, and also it is going to tell what is going to be the result of that particular program. But if you want to see the reasons, means if you want to get the reasons how that program has given these results, so such kind of knowledge you cannot get it from the declarative knowledge. So for that one you need to make use of the procedural knowledge. So because of these things, we can say that the declarative knowledge is even also called as a descriptive knowledge. It will just give a description, but it will not give you the reasons. A statement in which knowledge is specified, but the use to which knowledge is to be put is not given. So this is an important point. So if we talk about this laws, okay, the legal laws, we can say the people's names. So what we can say, these are completely the independent facts. These are the independent facts. So it does not have, they are not going to be dependent on any other kind of knowledge. So we say that these things, names of the people or about the laws, they all comes under the declarative representations. So what do you mean by we are going to have a program that explains what is to do with the knowledge, what is to do, what we can do with that knowledge. Okay, but how we are not going to see in this particular case. So in simple words, we can understand this point also. What is that? A declarative knowledge is going to have certain kind of facts which are going to be the standalone. Standalone in the sense they are going to be independent to each other. They are not going to be dependent on any other knowledge. So the best examples are laws, some people names like that. Let us try to understand the logic programming. So in artificial intelligence, this logic programming is a very, very important point. Okay, so what do you mean by logic programming? We can say it is a kind of technology that comes fairly close to embodying the declarative statements. So whatever the declarative statements we have discussed so far, that statements we need to convert it into the program. We need to convert it into the program. So before converting into the program, there will be another step, we can say. Means first we are going to have the declarative sentences. So these declarative sentences we need to convert into logic, and later this logic we need to convert into a program. So this is the actual procedure to write the AI programs. Means AI programs cannot be written directly until and unless you have these declarative statements. Until and unless you represent the declarative statements in the form of logic, you cannot able to convert it into the program. So that's why we say that writing of AI programs is too complex when compared with the other programming languages. So the system should be constructed by expressing knowledge in the formal language. Okay, so in this case, what we do is we will try to make use of this knowledge. Okay, so if we have the knowledge in our hands, so it will be very easy to convert this knowledge into program. So how we can do means by running the inference processes. Here, what do you mean by inference process? Means trying to extract some additional knowledge, trying to extract some new knowledge from the already existing knowledge. Okay, so based on that, we can we can make use of these inferences. Inferences is nothing but here giving some kind of conclusion. Okay, moving towards the conclusion state, we can say. So if you want to move towards a particular conclusion state, so simply having some declarative statements will not work to us. So you should supposed to know how to convert the declarative statements into logic, and also you should supposed to know how to convert that logic statements into the AI program. So in simple words, this complete process is going to talk by the word called as algorithm. So the algorithm, so according to this person, Robert Kowalski, what he is telling is the entire process is represented in the form of a particular equation, saying it as algorithm is nothing but the logic plus the control information. So how we are going to get the logic? Again from the declarative statements. So by using some predicate logics, either it can be first order predicate or second order predicate logics, or sometimes if your problem statement is so simple, you can go for even the propositional logic also. But anyhow, the declarative statements need to be converted into logic, and we need to add up that logic with the control information. Why? Because this control information is only going to tell which rule need to be applied at what time. So if you combine the logic and the control information together, then we say that it is an algorithm. Okay, so this is a statement given that by this particular person. So what we are going to do this with logic programming. So there are different kinds of logic programmings are available. I mean, the most common one is Prolog and Lisp. So in this particular sessions, means especially during our artificial intelligence and expert systems course, we are going to learn about the Prolog programs. Okay, so what is Prolog program? So just now we discussed that from the logics only, means from the logics only we are going to develop these Prolog programs. So these Prolog programs are some set of clauses written in a notation somewhat different from the standard first order logic. So if you could able to represent the declarative statements in the first order predicate logic, that means that you have converted that statements, declarative statements, into logic statements. But logic statements are not the program statements, remember. So the Prolog program statements, again, that can be obtained by converting these first order logics only. So how can we do that is going to teach us by this Prolog. It is going to teach about this by this Prolog. So what this Prolog is going to have some clauses, we can say. Clauses in the sense it can be a fact, it can be a rule. Okay, fact or rule. It can be a fact or it can be a rule or it can be a relation. It can be anything. So in this Prolog, what happens? The uppercase letters are used for variables and the lowercase letters are used for the constants. So most of these clauses, they are going to be written in the backward case. In the backward case means the declarative statements is going to talk in this particular way. Okay, starting at the left hand side and moving and trying to explain and move towards the right hand side. But when it comes to Prolog programming, it is completely different. Means we talk in this way. Start from the right hand side and move towards the left hand side. You try to take this particular statement. So this is the one of the particular class, we can say this is one of the class which we have represented in the form of logic. So what this logic is talking about means A and B, which implies C. Means if you want to prove C, you need to prove A and B. Means first prove A and B, then after you try to prove C. Means the solving of A, means you can understand the solving of A and B can easily make to solve this C. Okay, this is the Prolog. This is not the Prolog representation. It is just a logic representation. Means we can say it is a first order predicate logic representation. But this is going to be entirely different. That's why we say that it is backwards. So in this backward, the representation will be reverse in the reverse case. So this is going to be the one of the class which we are going to write in the Prolog programs. So what does it mean? Means you try to observe this particular symbol we have changed, means it is changed into comma. So what do you mean by comma here? Comma indicates and. So we need to move in this particular direction. So in this case, what do you mean by it? Means if you want to prove C, first of all you need to prove A and you need to prove B. Then only you can able to prove C. So in this case, if you want to prove that C is true, so in that case you need to prove A is true as well as you need to prove B is also true. In that case, in this particular case only, we can say that C is also true. Okay, so this is a difference we are going to see while representing the declarative sentences in the first order predicate logic and as well as in the Prolog programming. Let us try to talk about the inference engine. So what do you mean by inference engine here? We can say that inference engine is one of the major component in the expert system. Okay, so what this inference engine is going to do means it is going to make use of the logical rules present in the expert systems. So for what purpose it is making use? In order to analyze and interpret the knowledge in the knowledge base. So we can say that the analysis and interpretation part during the problem solving, it is going to be done in the inference engine by making use of the knowledge that is available in the expert system. Okay, so it then provides an answer. Means after performing this analysis and interpretation, it is going to provide some answers based upon the facts gathered from the knowledge base. Okay, even if the inference engine is giving the different kind of result, that means that our knowledge base is not good enough. So we cannot blame the AI machine or an AI agent in this particular case. So the completely answer giving by the AI agent is going to depend upon the knowledge you are supplying. So the analysis and interpretation is going to be correct whenever your knowledge is correct. And at the same time, we can say, after doing this analysis and interpretation, we are going to generate the new information. The information which is hidden before performing this analysis and interpretation. So we can say that inference engine is going to help us in order to extract or in order to unhide the knowledge which is already available. So we can make use of that hidden knowledge and we can solve the problems in a simple way. Let us try to talk about the expert systems. So expert systems is also one of the major component. So it is a major system. It is a system where inference engine is one of the component and knowledge base is also one of the component. So along with the inference engine, knowledge base, we are also going to see the control information, which is going to tell what rule need to be applied at what time. So we can say that this knowledge expert systems are of two different types. So the first type is a knowledge based expert system. So in this case, what happens? The inference engine is going to acquire and manipulate the knowledge from the knowledge base to obtain a solution. So in order to get the solution, it is going to make use of the knowledge from the inference, knowledge from the expert system, and it will do certain kind of manipulations. It will do certain kind of knowledge manipulations of such knowledge. So in this case, we can say that it is a knowledge based expert system. And also we are going to have another type which is called as rule based expert system. So in simple words, we can say that knowledge-based expert system is going to concentrate on the knowledge, right? Means how the knowledge can be framed, means how the knowledge can be framed in a proper way, how we can make it a good quality and good quantity. But when it comes to rule-based expert system, it is not like that. It completely concentrates how we are going to apply the rules. How we are going to apply the rules. And at the same time, it is going to concentrate on how the new knowledge can be added to the knowledge base. So as I said, the preparation of knowledge base is not a single time process. It is a repeated process. So in that repetition case, we can say that knowledge base expert system is going to play an important role in order to acquire the new knowledge about a particular problem domain. And this rule-based expert system is also going to help us in order to resolve the conflicts. So what do you mean by conflicts? In some cases, what happened, there will be some particular state where more than one rule is applicable. So if to this particular state, rule 1 may be applicable, and at the same time, rule 2 is also applicable. So in this case, which rule need to be applied? So this is a conflict. In order to overcome this conflict, we are making use of this knowledge-based expert system. So in this knowledge-based expert system, we are going to have the control information. That control information will tell exactly whether this R1 is considered or we can consider R2. Okay, so that's why we can say that rule-based expert system is helpful in order to solve or in order to resolve the conflicts. So we can also discuss like this. So rules generated from previous applications. Rules generated from the previous applications, we can say that it is a repeatedly to facts. Applying rules repeatedly to facts. So if you say that knowledge base, if you say the knowledge base, it is nothing but representing the facts about the knowledge. Representing the facts about the knowledge, or we can say that some kind of observations about a particular problem domain. Let us talk about other definition which comes in module number 2, which is called which are forward reasoning and backward reasoning. So while resolving the problems, any AA problem you take, either you need to follow the forward reasoning approach or you need to follow the backward reasoning approach. So in other terminology, we can say that forward reasoning and backward reasoning as forward chaining and backward chaining. So this is completely depends upon the search. Means if your problem is related to the search activity, then these kind of reasonings are very, very important to us to understand. So a search procedure must find a path between the given initial state and the goal state. So if your problem is in order to identify a particular path in between the given states, so first what you need to do, you need to perform the search activity. So that search activity either you can perform in the forward way or you can perform in the backward way. So what do you mean by forward way here? Means which starts from the start state. So we can say from the given state towards the desired state. But when it comes to the backward reasoning, it means that starting from the goal state. Means we are not going to move from the given state, but we are going to move from the desired state. Okay, so that's why we say that it is a forward reasoning and backward reasoning. So you try to observe what happens next. The forward reasoning is going to talk about what happens next or follow certain kind of conditions and deduce the outcome. What is going to be the next step? Means while playing the chess game, right, what is the next step to be done? What is the next step to be made? Like that it is going to be continued. So until where? Until we get to the outcome. So in simple words, we can say that we are going to follow certain kind of action, certain chain of actions or certain chain of conditions, or we can say certain chain of legal moves during the chess playing game. Okay, so by following this, if we could able to start from the starting state and move towards the outcome state, means the desired state or the goal state, then we can say that kind of reasoning or that kind of chaining as the forward search chaining process or forward search. If it is a backward search, just now we discussed, it is going to start from the goal state. So why this happened? So we are going to talk about the point why this happened. So the situation is already happened. So why this happened? So in this case, means in the backward reasoning, we are going to find the cause or the reason behind it. Means what made to happen something. What is the reason behind it? So such kind of inferences we are going to generate from the backward reasoning. So this initial state is fetched based on the decision. Okay, it is going to be based on the decision. So in simple words, we can say when it comes to the hospital domain or health domain, the doctor will always think about, always try to follow this backward chaining only. Means what are the reasons that made the patient to get ill, to feel ill. Okay, but when it comes to the patient, it is not like that. Means already the situation is happened. They are going to they are going to consider about the next thing. Means how we need to recover from that point. So in simple words, we can say the patient is going to follow the forward reasoning and the doctor is going to follow the backward reasoning. Means he will try to go back and he will try to observe what are the reasons that made a patient to fall ill. Okay, so these are the some of the definitions related to our second module, and these definitions I have collected from this reference. Hope you understood. We will try to come up with other definitions and terminologies in the coming session. Till now, thank you.
Like, share and subscribe. Hit the bell icon for more updates.